Okay, so in this video we're going to look at density. The first thing you've got to remember is either the formula for density, which is mass divided by volume, or you need to recall the triangle so then you can derive the formulas. So if I was wanting to work out density, and I'm just going to write these down so we've got these for the future. So if I wanted density, because mass is over volume, it would be, I'm just going to be lazy and write mass divided by volume. If I wanted to work out volume, which again is on the bottom of the triangle, mass is over density, because one's on top of the other using our formula, so mass over density. And finally, if we wanted to use this triangle to work out mass, it would be density times volumes, because these two are sat next to each other. So we need to be confident in the order in which we place these into the triangle to ensure that we're using the correct formula. So I'm just going to talk through some of the GCSE style questions that we may see, and they do range from 2-mark questions up to 6-mark questions. So I'm going to start off with quite a straightforward question. It's asking me, I've got the volume of a piece of wood is 620 centimetres cubed, I know its density, and I've been asked to work out its mass. First thing I'm going to draw myself is a triangle. I know its mass on top, density and volume. So looking at this question here, it's asking me to calculate the mass. So I know to calculate the mass, it is the density times the volume. So these two multiplied together. The density of this piece of wood is 0.85 grams per centimetre cubed, and I'm going to multiply that by 620 centimetres cubed. This and this both have the same units, so therefore I'm not going to make a mistake. And then I just need to type that into the calculator. And that gives me an answer of 527. And I know that is in grams, gives me grams on the answer line already, so I just need to repeat my answer down below. And that's it. Okay, so let's have a look at another question. So this one here is from one of the OCR practice papers. It tells us an alloy is made from 28 centimetres cubed of copper, 41 centimetres cubed of gold. From science, hopefully we recall that an alloy is a mixture of the two metals. It tells me the density of copper is 9 grams per centimetre cubed and the density of gold is 19 grams per centimetre cubed. First of all, asked to work out the mass of the copper. So again, before I do anything else, I'm just going to draw my triangle so I know I don't make a mistake. So I've got mass, got density, and I have got volume. I'm interested in this one in just copper. So the information I've got about copper is 28 centimetres cubed of copper, and I know its density is 9 grams per centimetre cubed. So first thing I'm just going to make a note of is the volume is 28 centimetres cubed, and I know what its density is. I'm working out the mass. Mass, as in the previous question, means that I'll multiply the two together. So 28 times 9 and calculate what it comes to, which is 252 grams. The next question is asking me to work out the density of the alloy. So to do that, what I need to be able to do to work out density, if we recall, density equals mass divided by volume. So I know that the density is equal mass over volume. Now I know what volume I have of both, but I don't know what mass I have of both. So before I do anything else, I'm just going to lay out the information I have. So with respect to copper, I've got the volume, which is 28, I've got the density, which is 9, and now I also have its mass, which is 252 grams. I'm just going to go back and make sure I've got the correct units. So what do we have for gold? So for gold, so far, I have the volume, which is 41 centimetres cubed. I have the density, which is 19 grams per centimetre cubed, but I don't have its mass. So to be able to work out the density of the alloy, which is mass divided by volume, I need to know the total mass that I'm working with. So I need to know what the mass for the gold is. Well, we've just worked out mass in the previous one, and we said that mass is density times volume. So I'm going to do 41 times by 19, and I'm going to work out what the mass of the gold is. And this is 779 grams. So now to look at the alloy. So my volume, the total volume I've got is going to be the 28 and the 41. Which gives us 69 centimetres cubed. We want to work out the density, so what mass have we got? Well, we've got 252 and 779 grams, which gives us a total of 1031 grams. From there, I can then go on and work out the density. So we said that density is mass divided by volume. So it's 1031 grams divided through by 69 centimetres cubed, and that gives me an answer of 14.94 if I'm to round it to 2 decimal places. It doesn't tell me what I need to round it to. You can write down the whole number, it's not a problem at all. Remember, density with respect to the units is grams per centimetre cubed. I can double check that looks roughly correct. I have more gold than I do copper, so therefore I'd expect the density to be closer to that of gold than I would of copper. Well, ours comes out at 14, so that sounds like a sensible answer. Okay, so this time we're going to look at a slightly more worded question. So we have a truck is used to transport some wood panels. Each wood panel is a cuboid measuring 2.4 by 1.2 by 1.8. Now if you notice here, 2.4 is in metres, 1.2 is in metres, and they bold the centimetres here. Therefore, they're hoping that you will notice, but these are not in the same units. These need to be in the same units. If we then look at the information on the next line, the density of each wood panel is 750 kilograms per metre cubed. Therefore, I need to turn this 1.8 centimetres into metres to be able to then carry on and do the calculation. So if we recall that 1 metre equals 100 centimetres, so therefore to be able to get this into metres I need to divide through by 100, which gives me 0.018 metres. So I'm just going to write this above so I know I'm going to be working with the correct units. The truck can carry 15 tonnes of these wood panels. Calculate the maximum number of wood panels that the truck can carry and show how you decide. Now, because we've got density in the question, I'm going to do what I've done previously, and I'm just going to draw my triangle. So I've got M, D, V. I haven't at the moment got anything linking to volume other than the fact I've told I've got a cuboid and it's 2.4 by 1.2 times 0.018 metres. So before I do anything else, I'm going to calculate the volume of a wood panel. It's a cuboid, which you remember is length times width times height. So I'm going to do 2.4 times 1.2 times 0.018, and I'm going to calculate the volume. And that comes out at 0.05184. meters cubed. So I know what the density of the wood panel is because I've been given that in the question. It tells us that the truck can carry 15 tonnes of wood pallets. Well, here we've got kilograms, here we've got tonnes. So we need to know the conversion between kilograms and tonnes. So 1 tonne, and this is information they're expecting you to recall, is 1,000 kilograms. So therefore 15 tonne means we're going to multiply this through by 15, which gives us 15,000 kilograms. So my next step is I know the volume of a wood panel and I know the density of each wood panel, so I'm going to work out the mass of each wood panel. Well, we know mass equals density times volume. So we know the density from here, so I'm going to have to do 750 times by this value here, which is 0.05184. And that gives me an answer of 38.88, and it's, if you remember, in kilograms. We know the truck can carry 15 tonnes, which we've already converted into 15,000 kilograms. So the amount that can be carried means we need to take our 15,000 kilograms and we're going to divide 38.88 kilograms into it to see how many can be carried. And your answer comes out at 385.802, etc. So we then need to say how many can be carried. So the answer for this one would be 385 panels. Okay, so this question here looks slightly more complicated. So it says the length of each side of a plastic cube is 2A millimeters. The cube has a mass of 32A squared grams. So we're now talking of a question that is linking to algebra. Find an expression for the density of the cube in its simplest form. Give the units of your answer. Now this is a 5-mark question. As always, I'm going to write down my triangle. So I've got mass, I've got density, and I've got volume. So I know the mass. At the moment I don't know the volume, but I do know that it's a cube. So I'm going to work out the volume of the cube. So volume equals, well, each length is going to be the same, so it's going to be 2A cubed, or if you'd prefer to write it out, you do 2A times 2A times 2A. So 2 times 2 times 2 gives me 8. A times A times A gives me A to the power of 3. So the volume is 8A cubed. We know the mass, so let's write that one down. So mass is already given us for us. I'm just going to make sure we've got the correct units here as well. So we've got 32A squared grams, and we want the density. So density is on the bottom of a triangle. So density is mass divided by volume. The mass is here is 32A squared, and the volume is 8A cubed. I'm just going to leave for the moment the units and I'll come back to that. So I've got 32 divided by 8, so I'm just looking at the numbers first, which is 4. I've got A squared divided by A cubed, which I can write in 2 different ways. So I could either write it as 4 over A, or I could write it as 4A to the minus 1. When I'm dividing with powers, if they have the same base, then I just subtract these. So like I said, it doesn't matter how you write this, it's exactly the same. So we've got the density. What we now need to do is make sure we know what the units are. So the mass was grams and the volume was in millimeters cubed. So all I need to do is write grams per millimeter cubed, and either of these will be sufficient. So I'm going to write it as 4 over A. So whilst it might look like quite a complicated question, if you just follow through using the information you know about the volume of a cube, you know the mass, carry through and do the calculation for density, use your powers of indices, laws, to be able to then simplify your algebra. And remember, when you're working out your units, take whatever unit you've got for the mass, goes on the top, whatever you've got for your volume goes on the bottom, and then we just write it with the line between. Okay, so let's have a look at the next question. So this time we've got a sculpture and it's formed from a cylinder resting on top of a cuboid, which we have here. It tells us the cylinder has a radius of 45 centimetres and a height of 80 centimetres, and the cuboid measures 90 centimetres by 90 by 150. The sculpture is made of granite and the granite has a density of 2.7 grams per centimetre cubed. We're asked to work out the total mass of the sculpture in tonnes. So let's have a look at what we've got. So we've got the density. So before I do anything else, as I've done previously, I'm going to write down my triangle. So I've got mass, density, volume. We have got the density. So I'm just pulling out the key information that I already have. So the density is 2.7 grams per centimetre cubed. We want to calculate the mass, and at the moment we don't have any of the volume calculations, but we are given sufficient information here to calculate the volume. So that's going to be our first step. So we're going to look at calculating the volume. I'm going to look at calculating the volume of the two shapes. So I'm going to do the volume initially of the cuboid because that's a nice straightforward one. So to work out the volume of a cuboid, if you remember, we're multiplying length times width times height. So I'm going to do 90 times 90 times 150. All of these in the same unit, so I don't need to do any conversions, and just multiply them all together. And I'm just going to write down the value that I get. And remember, it is in centimetres cubed. Next, I'm going to do the volume of a cylinder. So you do need to recall the formula for this. If you remember what that is, it is pi r squared times by the height. We are given the radius as 45 centimetres, therefore it's pi times 45 squared times by 80. So that gives me the following. I'm going to write down everything that is on my calculator display so I don't make an error. So I actually want the total volume, so now I need to add these two together. So I'm going to add this one. Like I said, make sure you use the whole calculation. It doesn't quite fit on my screen, I'm afraid. So the volume is in centimetres cubed. So So we now have the density for the sculpture, we now have the volume of the whole thing, and then I now need to calculate the mass. So the mass, we know from the formula, is density times volume. So it's going to be the volume that I've just calculated with the density of 2.7. So it's 2.7 times this value here. Leave the calculation on your calculator so you don't have to keep retyping things in case you make an error. Now we need to check what this is in with respect to the mass, and this is going to be in respect to grams. However, the question is asking me to calculate the total mass of the sculpture in tons. So therefore I just need to do a few final steps. If I remember from previously, we said that 1 tonne, oops, don't know why I've done that, not going to let me rub it out. Okay, so 1 tonne is equal to 1,000 kilograms, and we should know that 1 kilogram is equal to 1,000 grams. So we currently have this in grams. I'm going to have to divide through by 1,000 initially to get it into kilograms, and then I'm going to have to divide through by 1,000 again to get it into tons. So my mass is 4.65. You can write down the whole calculator display if you like, tons. So as I've said, because I know that 1 tonne is 1,000 kilograms, and I know that 1 kilogram is 1,000 grams, I've taken my answer, I divided through by 1,000 to get it into kilograms, then divided through by 1,000 again to get it into tons.